right, so we're going to talk about solving quadratic equations. But before we do that, I want to go over what types of factoring we've discussed in this unit so far. So there have been 4 types of factoring that we've talked about. The first kind is GCF. Okay, the second kind is difference of 2 squares. The third kind is trinomial. And the fourth kind is the hard trinomial. This is when the coefficient of the x squared term is something other than 1. This is when you do the slide divide bottoms up. Okay? GCF is always the first type of factoring that we check for, so that's super important. Please keep that in mind. So we're going to be using the different ways that we've learned how to factor in order to solve quadratic equations. So before we get into that, I just want to do a little review that a quadratic equation is an equation in the form of y. Oops. I'm using a new stylus right now and having technical difficulties apparently. Y equals ax squared, oops, plus bx plus c. That's the general form of a quadratic equation, okay? So let's take a look at the first example. So I want to do 2 things. I want to write down what method we're using, and when I say method, I mean which one of these 4 types of factoring we're using, and then we're going to go ahead and solve. This is really just taking what we've already done with factoring and taking it just kind of one extra step. So if you look at the problem we have here, x squared minus 2x minus 15, you want to think to yourself, is there a GCF? If you look at it, you're going to see that there isn't, because all the terms don't have a variable. We don't have a number that goes into, 2 and 15. So this is going to be trinomial, okay? Okay? So just to kind of review what we were doing last week, we are looking for 2 numbers that are going to add to the 2 and multiply to the 15. So the first thing we're going to do is write down our factors of 15, which are 1 and 15, and 3 and 5. And just as a little reminder, you can get that by going into the calculator and hitting the y equals button, and then in your y1 you would type in 15 divided by x. You would hit second graph and you would look at the table and you would start at x equals 1, and you would write down all the nice whole number pairs. You wouldn't list anything that's a decimal. We're only looking for the nice whole numbers. So that's another way that you can get your factors. It's a faster way if you don't know them off the top of your head. So now let's go back to the factor list, and we're going to look at our pairs and think, okay, well, which pair, the 1 and the 15 or the 3 and the 5, can somehow come together to make that negative 2 in the middle? So if you think about 1 and 15, there's no way we can add or subtract 1 and 15 in any sort of combination that would end up giving me a negative 2. But we can do that with the 3 and the 5. Okay, so that's going to be the pair of numbers we're going to use. So let me just go back over here. So you're going to start off with your double bubble. And we've got x and 3 and 5. And now this is the tricky part, is figuring out what our signs are going to be. So you have 4 possibilities of signs. You could have plus 3, plus 5, plus 3, minus 5, minus 3, plus 5, minus 3, minus 5. So plus 3 plus 5 gives us positive 8. Plus 3 minus 5 gives us negative 2. Minus 3 plus 5 gives us positive 2, and minus 3 minus 5 gives us negative 8. So, ding, ding, ding. Looking at the second one right here, that's giving us the negative 2, which is what we want, because that's what was in the original problem. So that means that my 3 is getting the plus, and my 5 is getting the minus, okay? So that part, up until this point, you had seen this, or at least I hope you have seen it, because I've been making these videos. So, now we're taking it one step further. We're actually solving. And another way that you can kind of tell the problem's a little different is just by looking at the fact that we have this equals 0. So that right there is kind of a hint that you want to end up with x equals something, okay? Because it has that equal sign in it. So now, what our next, pick a different color. What our next step is going to be then, so this right now is new, what I'm about to show you. We're going to do something called teeing off. So we are going to tee off our two factors. And what we're going to do is we're going to take each factor, the x plus 3 and the x minus 5, and set them each equal to 0. So I'm going to go like this. X plus 3 equals 0. And then over here, I'm going to put x minus 5 equals 0. Now, the reason that we're doing that is because if I have, so I'm looking right here right now. If I have two things that when I multiply them together, I get 0, what that means is that at least one of them has to be equal to 0. So either both of these are going to be equal to 0 or one of them is going to be equal to 0 because of the fact that when you multiply them, you get 0. Don't worry about that too much, just a little bit of an explanation in case you were wondering, which I'm sure you weren't. All right, so now over here with the x plus 3 equals 0, we need to get the x by itself. So we're going to subtract the 3 on both sides. And 0 minus 3 is negative 3. Now over here we have x minus 5 equals 0. We want to get the x by itself. So we're going to add 5 to both sides. And we get x equals 5. And that, ladies and gentlemen, are our two answers. Okay? Now, if you're looking at the answer key that I posted, you can also write the answers like this as a solution set. So when you do that, you do your little curly bracket, negative 3 comma 5, and then another little curly bracket. That's called the solution set. You can write it that way, you don't have to, but you might see it like that as the answer choices for multiple choice, so just be aware of that. All right, let's move on and try number 2. Doing the same thing, we're solving. Now, remember we were talking about before that the first kind of factoring we always check for is GCF. Now, this one starts off looking like the one we were just doing, but if you look a little bit more closely, you'll notice that we have a term that has an x squared and then a term that has an x, and then that's it. We don't have then that c term or that constant term, which is the number that's just all by itself. So we only have 2 terms here. So now let's think about the GCF issue. So let's just look at the numbers to start off with. Between 2 and 4. Okay, let's list our factors of 2 and our factors of 4. So our factors of 2 are 1 and 2, and our factors of 4 are 1 and 4, 2 and 2. And you can see kind of right away that the biggest factor that they both have is 2. So our GCF starts off by just being equal to 2. But now, let's go back again. Now remember that this little x over, that didn't come out the way I wanted, that this little x over there has an invisible 1 as an exponent. Since both of our terms here, and I'm not don't look at this part right now. For right now, pretend that part's not there. Both of our terms have an x. So that means that we are going to have an x as a part of our GCF. Now the question is, well, what's the exponent going to be? We always take the lower exponent, which in this case is x to the first. So then the GCF ends up being 2x to the first, or you can just also write it as 2x, okay? So we have figured that part out. So now what we're going to do is we're going to divide each of our pieces by our GCF, which is 2x to the first, okay? So now looking at the first term, 2 divided by 2, that simplifies to 1. And then x squared over x to the first. Remember that we subtract our exponents, so 2 minus 1 is 1. So we're left with x to the first, or you could just write x, minus, now 4 divided by 2 is 2. And then the x's on top of each other, since they're both exactly the same, they actually cancel out. So you don't even need to worry about that anymore. But we still have, don't forget, you have to bring down that 2x. That didn't go away. And we also still have the equal 0. Okay? So now at this point, this is now where we're going the extra step to actually solve for x. So we're still doing the t off in between the two factors, except the only difference now is that here, the first one, the 2x, isn't inside of a bubble. Well, that's because 2x is a monomial. If it was inside of the bubble, it would be a binomial. It doesn't matter. It doesn't change the problem at all. So what you're going to do now that we drew our t is we're going to set each one of our factors equal to 0. Okay? So looking at the first one, 2x equals 0. If I want to get x by itself, I need to get rid of the 2. Now the 2 and the x are being multiplied, and the opposite of multiplying is dividing. So we're going to divide both sides by 2, and 0 divided by 2, or 0 divided by anything actually, is 0. Okay? Now let's go over to the second one. We've got x minus 2 is equal to 0. So we need to get the x by itself, so let's add 2 on both sides. And we get x equals 2. And ta-da! Here are our answers. And just be aware that you can also write it as a solution set, a curly bracket, 0, 2, and curly bracket. Okay? So that's the gist of what we're going to be looking at in this packet. I want to actually go now to the next page. Now all these notes are posted on Google Classroom, so there's nothing here that you have the answer key to this whole thing, but I do want to go on to page 2 and just go look at where it says steps for solving quadratic equations algebraically. So we're just going to list the steps that we just did. So the first thing was that we factor. Whether that be GCF, dots, trinomial, or hard trinomial. Our second step is that after we've factored it, we t off. And when we do that, we set each factor and set each factor equal to 0. And then after that, you solve the equation. You solve for your both answers. Now the fourth step is a step you don't have to do. This is the check. Now, I know you guys have done checks in the past. I know you don't like them. You don't have to do it. The check would just be taking your answers and one at a time replacing them back into the original problem and just making sure that you get both sides of the equation to be equal to the same number. In this case, it would be 0 equals 0. You don't have to do that, but it is a good way to see whether or not you have the right answer. Okay? All right, so we're going to do just a few. I'm just going to go through a few questions on this, on the video, because the rest of it is on Google Classroom. So let's take a look now at question 4. Oops, question 4. Hang on. Okay. So we've got x squared plus 4x plus 4 equals 0. So if you look carefully at this, you'll see first thing we want to check for is there a GCF? Well, you've got 3 terms. The last one doesn't have an x and the other 2 have x's, so you're not going to have a variable being a part of it. And then the x squared has just the invisible 1 in front, so there is no GCF. It's definitely not dots because that's 2 terms, so this is going to be trinomial. So we are right now looking for 2 numbers that are going to add to the 4 in the middle and multiply to the 4 at the end. So what I'm going to do is list our factors of 4, which are 1 and 4, and 2 and 2. And then you want to ask yourself, okay, well, which pair of numbers can somehow come together to make the 4 in the middle? So that's going to be the 2 and the 2. I can't add or subtract 1 and 4 in any way so that I get 4. That just doesn't make any sense. So we're going to be using 2 and 2. So let's go back over here. And now we are going to do our double bubble. Don't forget to bring down your equal 0. And X is in the front. 2 and 2. Now, as far as finding signs, this one's actually pretty easy. We don't even need to sit and like go through our options the way I usually do on problems, because if both of the signs are plus, like in this problem, that just means that both of the signs in the bubbles will be plus. So that's a little trick you can remember. If you don't remember it, just do the thing on the side where I, write down all the possibilities, okay? All right, so now what we are going to do is tee this off. And then we are going to set each factor equal to 0, okay? So now, for the first one, x plus 2 equals 0, we need to get the x by itself. So let's subtract 2 on both sides, and we get x equals -2. And if you look on the other side, it's actually the same thing, because both of our factors ended up being the same. So what happens here is that your answer of x equals -2 is popping up for both of them. So this has a special name when this happens. And if you were to write it as a solution set, what you would do is your curly bracket, and you would just write the -2 once, because it's still, the only answer is -2. It's just that you're seeing it twice. So now down here, sometimes the roots of the quadratic equations are the same number. These are called a double root. It may be written only once in the solution set. Okay, so in this box right here, once. Okay? All right, but again, the procedure is exactly the same. Okay, let's go to the next page, and I want to, now the next question, number 5, the same thing. The only difference about number 5 is that, hang on 1 second, this is a slide divide bottoms up, because you've got the 2 in front of the x squared. But again, I have all of the work on the answer key. So I want to actually go down to this middle part right here where it says the answers of the quadratic equations are referred to as. So you have actually 4 ways that a question or a problem could refer to the answers. So the first way, this is really in no particular order, but one option would be they could ask you to find the solutions to the problem. They could ask you to find the roots. They could ask you to find the x-intercepts. We'll talk about what that means in a second. Or they could ask you to find the zeros. Okay. Now, these 4 things all mean the exact same thing. They all mean solve for x. It's just that there's multiple ways that you could be asked how to solve for x, and it would be one of these 4 ways. A question could say find the solutions, find the roots, find the x-intercepts, or find the zeros. Just be aware of the wording. All of those mean the exact same thing, what we just did. Okay, now the graph of a quadratic equation is called a, you know this word, parabola. Okay, now we're going to talk about how our answers to these problems actually relate to what's happening in our graphs. So if you go to the next page, so if you look at number 1 on the next page, we've got y equals x squared minus 9. Now, I'm just going to be drawing sketches here. We're not going to be drawing perfect graphs. Now, if you were to graph this is what you would end up seeing. And I'm just going to do the little sketch right here. If I can, hang on 1 second, make this a little bigger. Okay. This is what you would end up seeing on your graph. And forgive me for my very poor drawing skills. Okay. All right, now this is a parabola. Well, it's supposed to be a parabola. Now, looking at the graph, the parabola is intersecting the x-axis, which is the one that goes side to side, the horizontal, at two specific points. So over here, this is x equals -3. And over here, this is x equals +3. Ta-da! Those are your answers. So if you were to go back and factor this and tee it off and do it just the way we were just doing the problems algebraically, you would get +3 and -3. Well, if you want to relate that to what's happening in the graph, that is where your graph hits the x-axis. That's why they're also referred to as x-intercepts. Okay? So on the bottom, I wrote this down on the answer key, on the bottom of this page on the answer key, but I'm going to bring it up again, is that the solutions are where the parabola hits the x-axis. So the solutions are where the parabola hits the x-axis. It's very important to know that because it's really important that you have an understanding of how these problems algebraically and graphically relate to one another. Like just because something's happening algebraically, that doesn't mean that it doesn't also have a geometric significance to it. So looking at the second one, x squared minus 2x minus 15. So let's say you were to look at the graph, without solving, you would see this. Okay, my very poor rendition of a parabola. So, if you look carefully again, you will notice that our parabola is hitting the x-axis in two spots, at x equals -3 and x equals +5. Our solutions. Now, if you had originally done this problem by factoring and solving, you would have gotten -3 and 5. But again, just please understand that graphically what that means is that that is where it is intersecting the x-axis, okay? Now, the remainder of this worksheet is just more practice, and I have on the answer key on Google Classroom, I have it all written out, and I have all the steps written out. If you're looking over it and you still don't understand it, then please contact me. We can go over it through email, through Remind. We can do a Zoom, whatever works. Now, I just want to mention one thing, though, because I did give you 2 different lessons on this. So in the second lesson, hold on, okay, it's more of just really the same thing. The only thing I want to point out, let me just get to an example on this page. Okay, so let's look at like number 7, that is on page 4 of the day 3 packet that I had given you guys. So for this question right here, this is question number 7. It's asking, what are the zeros of the function x squared equals 8x minus 16? Okay, so this is still the same thing that we were just going over. It looks slightly different in this problem because it's not equal to 0. So right now, this is what they gave us. Okay. Now, before we can get into doing any of the, factoring and teeing off, there's one step we have to do before that. And we didn't have this issue in any of the problems we did in the previous packet. we need to make this side of the equal sign equal to 0. Whatever side the x squared is on, you need the other side of the equal sign to be equal to 0. If you don't have that, you can't solve the problem, okay? So let's think about how we can turn this side into 0. So if I want to get rid of something, so let's say I want to move that x squared. It's a positive x squared, so if I want to make it go away, I'm going to subtract, I'm sorry, not x squared, 8x, I'm sorry. If I want to get rid of the 8x, I'm subtracting the 8x on both sides. Boom, that's gone, okay? Now, I want to move the negative 16 because I need this entire side to be equal to 0. So the opposite of negative 16 is positive 16. I'm going to add that over here. Hang on one second. Okay, so let's see what happened now when we just did that. So on the right side, the 8x moved to the other side, so that went to 0. And the negative 16, that went to the other side, so that went to 0. So the right side of the equation now is equal to 0. That's what we wanted. But now we need to figure out, okay, well, how do I write this jumbled mess as a problem? Well, keep in mind that x squared, 8x, and 16, none of those are like terms. I know you're looking at the x's, but one of them is an x squared and one of them is an 8x. It's like a Diet Coke and a Coke. They kind of look the same, but they're not. So the way you want to write this then is just write it in order, starting with the x squared, then put minus 8x, then put plus 16. Okay, and now we are back to where we were in the previous packet. So now you're going to factor it. You're going to look for two numbers that add to negative 8 and multiply to 16. And I have faith in all of you that you can either do that on your own or you can look at my notes and base it off of that. So there is an assignment up right now that goes over this stuff. So if you're having any trouble, please contact me, watch the video, look at the answer keys and all that good stuff. And hopefully I'll talk to you guys soon. Bye.